Hello class, we're about to start section 2.2 subsets. The objectives. Recognize subsets and use the notation. We have a subset of. This notation means subset of. Recognize proper subsets and use the notation proper subset. Determine the number of subsets of a set and apply concepts of subsets and equivalent sets to infinite sets. Now, we have our subsets. There are situations where all of the elements of one set are also elements of another set. Set A is a subset of set B, expressed as A is a subset of B, if every element in set A is also an element in set B. The notation that this is not a subset of means that A is not a subset of B. Set A is not a subset of set B if there is at least one element of set A that is not an element of set B. Every set is a subset of itself. Example. Apply the definition of a subset to the set of people aged 25 through 29 in this table. Now, it says here the set of tattooed Americans in the 25 to 29 age group. Now, we have here every person in this set to the left of the subset symbol. And then also, this is a subset of the set of all tattooed Americans. And then this is also a member of this set to the right of the subset symbol. Now, example given. A is equal to 1, 2, 3, and B is equal to 1, 2. Is A a subset of B? No, A is not a subset of B. And the reason being is this here. In order for A to be a subset of B, that means that everything in A must be in B. B can have more, but A cannot have more than B if it's a subset of B. So the answer here is no. Now it says here, is B a subset of A? Well, let's go back here to A. I should have put A is not a subset of B. And that would be your no. Now we come here, is B a subset of A? Now we look here. If we look at B, B has 1 and 2, and A has 1, 2, and 3. But B, all of B is contained in A, so B is a subset of A. So that answer is yes. Now it says here, example, write the subset of or not a subset of and the blank to form a true statement. We have A and we have B. If you notice here, all the elements in A is in B. So A is a subset of B. Now we come here. We have X is a letter in the word proof. Any other letters in the word proof. And B is Y as a letter in the word roof. Okay, now if you look here, the word proof has an extra letter over roof. It has a P and roof does not. So that means A is not a subset of B. That's because it has more letters in this word than B does. Well, I should say more matching letters. Okay, now we come to C. We have X is the day of the week. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So this is all the days of the week. So A can be a subset of B. Because remember, if both of these are the same, then it's automatically a subset of itself. Okay, now we go to the next page. We have proper subsets. Set A is a proper subset of set B expressed as A is a proper subset of B if set A is a subset of set B and sets A and B are not equal. Okay, now true or false. Now we're asked if this is a subset of. So we have 1, 2, 3. Is this a subset of 1, 2, 3, 4, 5? And of course it is yes, because we have 1, 2, 3 here 1, 2, 3 here. So it is yes. Or let's use the proper words, it's true. Now we come here to B. We have 1, 2, 3, and this says it's a proper subset of 1, 2, 3, 4, 5. Now remember, in order for it to be a proper subset, first we have to make sure that it's a subset. We have 1, 2, 3 here. We have 1, 2, 3 here. It is a subset. Now for it to be a proper subset, this first set here must be different from this second set here, which means that this second set has more elements in it. So that is true. Now we come down here to C. We have 5, 7, 9. We have 5, 7, 9. They are subsets of each other. Now we come to D here. We have 5, 7, 9. And we're saying, is this a proper subset of 5, 7, 9? Remember, proper subsets means that the first set is a subset of the second set, but they cannot be the same. And since both of these are exactly the same, it is false. Now we have note. In the subset symbol, the subset of, the lower part of the subset symbol suggests an equal sign. Thus, in A is a subset of B. It is possible for sets A and B to be equal, but they do not have to be. And the proper subset symbol, which we have here, the missing lower line indicates that the sets cannot be equal. Thus, in A proper subset of B, it is not possible for sets A and B to be equal. Example, determine whether set A is a proper subset of set B. We have set A, we have dog, cat. We have set B, which is dog, cat, bird, and fish. Now, if we look here, A is a subset of B, and they are not the same, so it is a proper subset. So A is a proper subset of B. Determine whether set A is a proper subset of set B. We have dog, bird, fish, and cat. We have dog, cat, bird, and fish. Even though they're out of order, they have the exact same elements. So we know that A is not a proper subset of B because they cannot be equal. Now we start our next example. It says write the subset of the proper subset, both or neither, in the blank to form a true statement. Now we have A is basically X is a person and X lives in San Francisco. X is a person and X lives in California. Now we know San Francisco is a city within California. So that means that A is a subset of B. But look here. We know that A is a subset of B. But if we look at this a little closely, we know that San Francisco is contained in California. But we know there are other cities in California. So A could also be the proper subset of B. So the answer is both. Now we come here to B. We have A, which is 2, 4, 6, 8. We have B, which is 2, 8, 4, 6. Now if you notice here, we have all the exact same elements in both of these sets. So A is a subset of B. We know that it cannot be a proper subset because in order to be a proper subset, you cannot have all of the same elements. Now we come here to C. We have X is a man and X is a woman. Now we know that a man is not a subset of a woman, or even vice versa. A woman is not a subset of a man, so is neither. Now we come down here to subsets and the empty set. Let A equals the empty set and B is equal to A, B, C, D. Is A a subset of B? To show A is not a subset of B, we must find at least one element of set A that is not an element of set B. Since A represents the empty set, there are no elements in set A. Thus, there are no elements in A that do not belong to B. Because we cannot find an element in A is equal to empty set that is not contained in B, which is A, B, C, D. That means that A subset of B. In other words, the empty set is a subset of B. So it says with our example, let A equals the empty set and B is equal to 2, 4, 6, 8, 10. Is A the subset of B? And we want to explain why. Now, in our explanation, we know first of all that is A the subset of B. We know that's yes. And explain why. Now, what you can do in your notes, you could just rewrite what you have up here because basically this is the same as this example. So basically everything in here except for B, you have to write 2, 4, 6, 8, 10 instead of A, B, C, D. It's the same exact answer you would give for this example. So you can pause it and then write this out. Now we go here to example. Let A is equal to empty set and B is equal to 2, 4, 6, 8, 10. Is A the perfect subset of B and why? You could basically, it'll be yes. And actually this is the proper subset of B. And what you could do is this here. What happens is this here. We could use the same exact argument that we used here for the first example, except for, in addition to writing what you wrote for this first example, you will also have to say that elements in A are not exactly the same as the elements in B, because that's how you would get the proper subset. Okay, now we go to our next example. It says let A equals the empty set and B is equal to 2, 4, 6, 8, 10. Is B a subset of A? We would have to say no. And the reason being is all of these elements are not contained in A because A is the empty set. So you could put, again, I'll just repeat this so you could write this out. All the elements in B are not in A. That is why it is no. So you could pause it and rewind it and restate what I just said. Okay, now we come to the next example. It says let A equals empty set and B is equal to empty set. Is A a subset of B? And it'll be yes. And the reason being is they are exactly the same. Actually, we could put the sets are exactly the same. The sets are exactly the same. So that is your explanation for this example. Now we scroll down here. It says definition of the empty set as a subset. The empty set is a subset of every set, including itself. For any set B, the empty set is a subset of B. For any set B other than the empty set is the proper subset of B. Now we have the number of subsets of a given set. If a set contains any number of elements, say n elements, how many subsets can be formed? Fill in the table below. Look to see if a pattern appears that relates to the number of elements in a set to the number of subsets. For the sake of time, I included the filled out table here. If you notice, we have all the elements that you have on your table that are blank spots. If you notice here, we have the number of elements with the empty set is 0. Then we have 1 here for A, 2 for AB, and 3 for ABC. And then we list all of the subsets. If you notice, every last one of them has the empty set. No matter how they're written, the empty set is a part of their subsets. And we have the number of subsets as 1, 2, 4, and 8. Now, the question is asked, what do you notice about the relationship between the number of elements in the set and the number of subsets? Now we have this question, what do you notice about the relationship between the number of elements in the set and the number of subsets? Then also, do you notice a pattern with respect to the number of subsets? We have the answer to both of these here. it can be seen that when we increase the number of elements,